The teacher in this video is introducing the use of software as a tool for students, in this case in exploring problems involving linear programming. They will be using graphing software. The teacher is interested to learn how, in using the software, students are better able to engage with the problem itself. A colleague is in the room to help make observations.
Right, today we're going to do a little bit...
The students are already familiar with the principles of linear programming and have experience of the graphical method. First then, to set up the problem.
So first of all, I'm just going to give you a standard linear programming problem. So what I'd like to do first of all is perhaps discuss, see if you can formulate this into a linear programming problem, write down some inequalities on your mini whiteboards that would help you work through this problem.
So large.
What I find with linear programming, after having taught it many times, is that what they tend to struggle with is the setting up of the problem, so taking the information given in paragraph form and formulating inequalities from it. And also sometimes those tricky bits at the end of questions where it might be that they have to adapt their solution slightly. The idea with this activity was to help make that time-consuming graph drawing step that they are familiar with, reduce that down to something they could do quite efficiently and quickly on their phones, so that they had longer to discuss and really focus on those tricky parts of the question. So here is the scenario that we've got. Here's all the different inequalities plotted on the graph.
The students are to use the software on their own devices. First though, the teacher begins by showing how key features of the software can be used to help explore the behaviours of the inequalities dynamically.
And here, there we go, that's the point at which our objective function leaves the feasible region. So that would be our maximum value. So if I select that one, look at that point, there we go. There are three problems, so perhaps if I ask you two to start with problem 1, please. You two to start with problem 2. That would be
16x plus 12y. Did the y one work or not?
Yeah, the y one works. It just goes across.
Equals 7y is greater than 165. Is that correct? Yeah, so that gives us our feasible region.
What was good about this is that often by them plotting the graphs from their first attempt, some of them realised that they'd made a mistake because they spotted the error on the graph that this can't be right, and so it forced them to go back, and that was quite a nice process. So in a way it was a more efficient way of working. If they were still getting bogged down, I was able to then intervene and help them through those early steps. And again, they could do that quickly, whereas if they were plotting those graphs by hand, they wouldn't have the luxury to do that, and so they might be more hesitant to go to that next step. So this 1,920, tell me where that comes from.
Yeah, the amount of money they've got to put in to that.
So that's their budget, effectively. So we've got two different sets of money information here, haven't we? We've got the amount it costs to make and the amount of profit they will get. So I think we just need to perhaps revisit those two lines there and just see if we can process that information.
Okay.
There we go.
So the furthest point is going to be where the green crosses the blue. Yeah. So the coordinate 12.5, 7.5.
It's that point there, so it's like 32, meant to be less than or equal to 300. 186 plus like 296. I think that's like the closest you can get without it being like half a table.
1020.
Is it 1020?
Yeah.
I think it's P is 121, 120. I think, yeah, 120.
So how did you feel about using your phones in the lesson?
Felt it like speeded things up a bit. I guess it's a lot more accurate than pen and paper.
It's a lot easier to have it in a kind of fixed position, like a fixed gradient, because it was easier to move, so we knew the exact point. Because if you're doing it with a ruler, sometimes you favour one side a bit more and push it on a bit of an angle. And if you get things wrong, you can just kind of quickly change it.
But at least working this way, you're saying, I suppose, gives you more time to spend on the tricky bits, the bits that do catch you up.
Which is helpful for lesson time, because you can't really, it's harder for you to get taught that than it is to get taught how to draw a graph.
I know a lot of teachers are very nervous about letting students use phones in classrooms. There are times when it's not a good idea, but I showed them the basics about how to start to input the graphs, but they just have a familiarity, particularly because it's their own phone and how it functions, that they can very quickly pick these things up and work quite independently.
Yes, it was very empowering that the students each had technology they could use. It wasn't all dependent on the teacher at the front demonstrating the technology.
They now have individual confidence on that sort of software, so they could do that themselves in their own time if they're revising or they're doing a homework task that isn't focusing on the graph drawing.